what is the probability that the sum of the numbers appearing on top of the two dice is, question number 1, 7, question number 2, the sum is 12, and question number 3, the sum is less than 8. We have seen before, when we roll two dice at the same time, total possible outcomes is 36. Now let's find out what are favorable outcomes that will give us the sum equals 7. We have seen before again that when we roll two dice, the way we represent each outcome is we open a bracket, we put the value of dice 1 first, then we put a comma, then we put the value of dice 2 second, and then we close the brackets. So we open a bracket. Let's say we get the number 1 on dice 1. We put a comma. Now, what is the value on dice 2 that will give us, when we add the two numbers, will give us 7? It is 6. So this is the first outcome, which is favorable to our event, sum equals 7. So similarly, if we get the number 2 on dice 1 and number 5 on dice 2, we will get 7. If we get number 3 on dice 1 and number 4 on dice 2, we will get 7. If we get number 4 on dice 1 and number 3 on dice 2, we will get 7. If we get the number 5 on dice 1 and number 2 on dice 2, we will get 7. And finally, if we get the number 6 on dice 1 and number 1 on dice 2, we will get 7. So these are really the only 6 total outcomes which are favorable to our event, sum equals 7. So we say that the probability of the event of throwing two dice in such a way that the sum of the two numbers appearing at the top being equal to 7 will be equal to 6 divided by 36, or if we simplify, it will be 1 divided by 6. Now let's find out what is the probability that we get the sum equals 12. Again, total possible outcomes is 36. Now, favorable outcomes for this event will be, can you guess? It really will be 6 and 6. Because if we get any other outcome, if we add the numbers, we will not get 12. 6 is the highest we can get on dice 1 and 6 is the highest we can get on dice 2. If we add them, only then we get the number 12. So essentially, there is only one outcome which is favorable to the event, that sum equals 12. So we say probability of this event will be simply 1 divided by 36. Now let's take a look at the third and final example. The sum this time is less than 8. Notice here, the sum is not an exact number, it is a range. It's less than 8. So the sum can be 7 or 6 or 5, so on and so forth. So let's list out all possible outcomes for which we get a sum which is less than 8. So we can get 1, 1, 1, 2, 1, 3, 1, 4, 1 and 5, 1 and 6. If you look at each of these outcomes, we will, if we add the numbers, we will get sum less than 8, right? The largest is 1, 6, which will be, if you add it, it will be 7, which is less than 8, right? Now, similarly, we can get 2, 1, 2 and 2, 2 and 3, 2 and 4, 2 and 5. Can we get 2 and 6? No, because 2 plus 6 will be 8. Remember, we are trying to find out outcomes for which the sum will be less than 8. Similarly, let's keep going. So 3, 1, 3, 2, 3, 3, 3, 4. What about 3, 5 and 3, 6? Again, no. Similarly, 4, 1, 4, 2, 4, 3. Similarly, 5, 1, 5, 2, and finally 6, 1. So these are the only outcomes which are favorable to the event that when we add the numbers, the sum is less than equal to 8. So if you were to count how many of these outcomes are there, we will see there are a total of 21 such outcomes. So we say that the probability of this event, that is the sum of these two numbers less than, I shouldn't say equal to, it will be less than 8, will be 21 divided by 36. If you simplify, it will be 7 divided by 12.